Hi students. In this lecture, I am going to discuss problems from HC Verma. Let us see first one. Let's see the question given. A coin is sliding down on a smooth hemispherical surface of radius r. Find the height from the bottom where it loses contact with the surface. Let us see how to start. So condition given that it loses a contact. Loses contact means normal reaction 0. So first we have to focus the force equation. Let us make a diagram. So there is a coin, or you can say small object. It is now just pushed, means velocity almost zero. Okay. So since it is losing contact, normal reaction 0. That means now we have to focus force equation. Let us say it makes an angle theta with the vertical. So when it is about to lose contact, so it makes angle theta. Okay. If you observe number of forces that are acting on the object, since it is losing contact, now only force acting is mg, which is along vertical. Mg, which is along vertical. Now it's one component which is towards center that provides now centripetal force. That is, this is theta means this also theta. This is now mg cos theta. So centripetal force is mg cos theta. So mg cos theta. This is now centripetal force, which is equal to mass into centripetal acceleration, mv square by r. M into v square by r. That is known as centripetal acceleration. So we have taken first force equation. Now in this you can see theta is unknown and v also unknown, where v is known as speed of the coin at the time of losing contact. So equation 1. So we have two unknowns, theta and v. So we require one more equation. So if you are taking now coin and earth as a system, then for this system we can write conservation of mechanical energy. So since it is moving down, it loses gravitational potential energy, and that loss converts into kinetic energy. So here I am writing here loss in the gravitational potential energy. Initially height from the bottom. So taking this bottom as a reference level, initial height r. Now height is r cos theta. You can see here. Now present height, that is r cos theta. It has come down by a distance. It has come down by a distance r minus r cos theta. This gives us loss in gravitational potential energy. This loss converts into gain in the kinetic energy. Initially, it has no kinetic energy. Now it is having kinetic energy. So final value minus initial value. Okay. Now see what we have to do here. So I want to calculate theta so that we can find the height. At what height from the base it is losing contact. This is what we have to calculate h value. So h equal to r cos theta. Okay. So in the place of mv square by mv square, I can write mgr cos theta. Mgr minus mgr cos theta that is equal to, in the place of mv square, it is mgr cos theta. Okay, from equation 1, I am taking that. Now in this, first of all, you can cancel mgr. mgr, we can cancel. Wait, you're having here by 2, right? mv square by 2. Okay, by 2 is there. mgr is cancelled. Remaining is now, I can take cos theta to right side. Then it is 1 by 2 plus 1, 3 by 2. So 3 by 2 cos theta is equal to 1, right? From this, cos theta equal to 2 by 3. Okay. That means at what height from the base it is losing contact. That is 2r upon 3. That is our answer. Okay. So we have taken first force equation. Next, we have taken conservation of mechanical energy and solving those. Let us see next problem. Question number 32. Figure shows a smooth track which consists of a straight inclined part of length L joining smoothly with the circular part. A particle of mass m is projected up the incline from its bottom. Find the minimum projection speed v0 for which the particle reaches the top of the track. Okay. And next, assuming that projection speed is 2 v0 and that the block does not lose a contact with the track before reaching its top, find the force acting on it when it reaches the top. Okay, let us see first how to get the first one. So minimum projection speed to reach top of the track. So first make the given diagram. So angle is theta. Now there is one sphere. You can say this is now joining smoothly. Okay, joining smoothly. Now condition is that how much velocity we have to provide so that it just reaches top of the sphere. Okay. So here once again I'm taking conservation of mechanical energy. Let us see. You can see carefully how much height block has to reach up to this point. The corresponding height, this is L. This will be L sine theta. And you can see now this also angle same theta only. This total values are, and this is now r cos theta. So this remaining part, that is now r minus r cos theta. That means this block has to move through a height of, that a height equal to L sine theta plus r into 1 minus cos theta. R into 1 minus cos theta. Okay. So the kinetic energy we are providing here, if you assume that this bottom as reference level, initially no gravitational potential energy, only kinetic. This kinetic completely converts into completely converts into gain in the gravitational potential energy. That is mgh. H value. Substitute here. L sine theta plus R minus R cos theta. Okay. So from this we get the value of V, right? V naught. Now simplify this. Mass gets cancelled. So V naught equal to 2G into L sine theta plus R minus R cos theta. So taking for this under root means power is 1 by 2. Okay. Now in that next part, assuming that the projection speed is 2v naught and that the block does not lose contact with the track before reaching its top. Find the force acting on it when it reaches the top. See carefully. So when it reaches the top, force acting on it. First observe here how many forces are acting on the object. On the object. One is mg, gravitational force. Downwards, normal reaction upwards. Okay. Here nothing is mentioned. Is it normal reaction? Right? So we are taking now net force. Net force means mg minus n. Okay. Which is equal to, which is nothing but centripetal force. So in that position, mg minus n, this is nothing but centripetal force. That is equal to mass into centripetal acceleration. Okay. So here I am focusing what is the speed on reaching the topmost point. Then we can write mv square by r. Right. So for that, first take energy equation. So we are taking now conservation of mechanical energy to find the speed on reaching topmost point. Okay. See here what I am writing. Initially, at the bottom of incline, speed given to v naught. So kinetic energy half m square of 2 v naught. No gravitational potential energy. That is equal to mgh plus half mv square. Okay. We can see this is now h. Half mv naught square equal to mgh. Okay. So in the place of this one, I can write this is a half m 4v naught square, that is equal to, in the place of mgh, I am writing half mv naught square. Half mv naught square plus half mv square. Now simplify this through 2 gets cancelled. 2 cancels. We want mv square. Okay. That's why I'm not cancelling m here. This is 4mv naught square. This is mv naught square. Remaining is now mv square is equal to 3mv naught square. Okay, mv square is equal to 3mv naught square. So we want mv square by r. Therefore, that force I'm taking as F. So take it as F. So that F is nothing but centripetal force. That is now 3mv naught square upon r, because we want mv square by r. Okay. And that value, see how much? Already we are having here value of mv naught square, right? We can take 2 here. We get mv naught square. This is into 3 by r, right? So in the place of mv naught square, I can take 2g, 2mg. into 3, 6 mg, 6 mg. See what we get. It is now 6 mg into 3 m v naught square m v naught square 2 mg into 3, 6 mg. Right, coming to now, R is there. So I'm taking here R inside. Then see what we get. L sine theta by R, right? Let me cross check once. This is what is the calculation part here. V naught value. See what we got. V naught value 2g into. Okay, right. Now substitute here. Remaining is now 1 minus cos theta because by R, okay, 1. And this is a cos theta plus L by R sine theta. Okay. So just using this result, okay, in this one. Cross check once into 3. So 6 mg L by R sine theta. So L by R sine theta. 1. 1 is here minus by R. So it is a cos theta. Okay. That is now centripetal force. Or you can say this is a net force acting. This is net force acting at that instant. Okay. So in this question, they may ask like, what is normal reaction? Okay. And what we can do? We got now mv square by r, right? Then n equal to mg minus that value. Okay. Let us see next problem. A chain of length L and mass m lies on the surface of a smooth sphere of radius r, and that is greater than L, with one end tied to the top of the sphere. Find the gravitational potential energy of the chain with reference at the center of the sphere. Suppose the chain is released and slides down the sphere. Find the kinetic energy of the chain when it has a slit through an angle theta. Find the tangential acceleration dv by dt of the chain when the chain starts sliding down. Let us see. Right. First of all, make a diagram for the given data. Chain of length L. So we are taking now one sphere. So we are taking one sphere. There is a one chain whose one end is fixed to the top. Right. Condition is that R is greater than L. Okay. Right. Now first we have to find out gravitational potential energy of the chain. See how to calculate. So condition given that take the center of the sphere as reference level. So by taking this as reference level, so first of all, I'm taking one small element on the chain. Okay, take one small element. Let us take angle is alpha. Take a small increment here, a small change. That is now d alpha. Okay, now we are focusing this part of the chain. Its length equal to r into d alpha. Okay. Now for that element. Now this is a small element. Okay. So this element is now at a height. You can see corresponding height that is equal to r cos alpha. So its potential energy is its mass m by L into r d alpha. That is its mass m g h, height from the reference level, that is r cos alpha. This is the potential energy of that small part. Like this, we have take all small parts from alpha equal to 0 to up to here. So this total length is L. Okay. Then total angle will be, that angle will be. So we are taking limits alpha from alpha equal to 0 to up to up to L by R, right? See, total angle is how much? For this length L, the total angle corresponding one is equal to L by R. That gives us potential energy of the chain. See, calculation how much? First take constants outside. M G R square upon L. Remaining is now cos alpha d alpha, right? That becomes now sin alpha. Now take limits. It is sine L by R, right? Okay, now see second one. Find the gravitational potential energy of the chain. The first part over it. Second part. Suppose the chain is released and slides down the sphere. Find the kinetic energy of the chain when it has a slit through an angle theta. Right. So let me make a diagram for this one. Now chain will be, it has a slit through an angle theta. That means now chain will be, it will be like this. Okay. And you can see now this angle is theta. Then this angle will be, see how much? You can see this angle is equal to L by R. Okay. So total angle is now L by R plus theta. So here what I can do is, this I can take it as initial potential energy, initial value. Now present value means the final value. See where change comes. The only change comes while taking limits. Okay. Now limits will be from theta to theta plus L by R. So taking the same thing. Only change is now, it is limits. Theta to theta plus L by R. So it is now sine theta plus L by R minus sine theta. That is now final potential energy. Initial value is greater than final value. That loss in gravitational potential energy converts into kinetic energy. Okay. So increase in the kinetic energy. Now see what we can write here. Or take here. That kinetic energy initially is 0. Now it is equal to half mv square. This is a kinetic energy equal to initial value minus final value. So I can take mgr square upon L outside. Mgr square upon L outside. Remaining is now sine L by R minus sine L by R plus theta. Minus of minus becomes a plus sine theta. That is now continuous. Okay. Next, now coming to the third part, find the tangential acceleration dv by dt. Okay, dv by dt of the chain when chain starts sliding down, starts. That means theta equal to 0. Okay, now see in that what I am doing. We can cancel m here. So you can cancel m and take 2 here, or you can differentiate directly here only. So I am differentiating that half derivative of v square 2v into dv by dt. That is equal to gr square upon n. This is a constant. So derivative 0 minus derivative of this one. It is a cos L by R plus theta into d theta by dt. So we should not miss it. Derivative of the inner function plus sine theta, that becomes now cos theta into d theta by dt. Okay. Now simplify this. 2 gets cancelled. In the place of d theta by dt, in the place of d theta by dt, it is omega, which is equal to v by r. Okay, v by r. So v cancels there by r, and one r cancels here. Remaining is now dv by dt. That is equal to gr upon L. Now he is asking when it starts sliding. Starts sliding means theta equal to 0. So theta is 0, theta value is 0 here. So it becomes cos 0, 1. So it is 1 minus cos L by R. That is now tangential acceleration. Okay. Let us see next one. Let's see the question given. A smooth sphere of radius r is made to translate in a straight line with a constant acceleration a. A particle kept on the top of the sphere is released from there at zero velocity with respect to the sphere. Find the speed of the particle with respect to the sphere as a function of the angle theta it slides. Let us see how to start. Right, first make a diagram. It is a sphere. It is a smooth sphere which translates with a constant acceleration. It translates with a constant acceleration. So now we are releasing a particle on the top. Okay. And asking here, find the speed of the particle with respect to the sphere as a function of the angle theta. Asking with respect to sphere. So solve the question from the sphere frame. It is now having acceleration. Therefore, it is a non-inertial frame. That means we have to include pseudo force. Let us do one thing. Let us say at one point of time that a particle is somewhere here. Line showing that particle to the center makes an angle theta, makes angle theta with vertical, makes angle theta with vertical. See how many forces are acting on that. One is normal reaction. Next, mg, which is always vertically downwards. mg. Since we are solving from the sphere frame, which is a non-inertial frame, we have to take pseudo force, that is left side, ma, right? Only three forces are acting. So here initially speed was 0. Now we have to find the speed. That means we can focus now work energy theorem. Okay. That means I can write here by normal reaction work done, by gravity work done, by pseudo force work done. Net is now delta K. That is a half mv square minus 0. And you can see normal reaction is always normal to the tangential. If I am taking any small displacement, it is always normal to displacement. So by this, no work is done. Okay. Remaining is now gravitational force and pseudo force. And luckily, these two are constants. Okay. Therefore, you can see pseudo force constant ma. So focus now. Component of displacement along the force, and that is now r sine theta. Displacement component along the force. So directly I can write here ma into r sine theta. In the same way, coming to weight mg, this is also constant. Therefore, take component of displacement along the force, that is r minus r cos theta. Initially height r, now height is r cos theta. So displacement component along vertical r minus r cos theta. Okay, substitute here mg into r into 1 minus cos theta. That is work done by gravity. Next, by pseudo force ma into r sine theta. That is equal to half mv square. So remain just calculation part. Now see, we can cancel m. So v square root of 2 to what I can take outside. I can take r outside, 2r. Remaining is now, I have taken 2 outside. It is a sine theta. It is a sine theta. Next, a sine theta. Here r outside plus g into 1 minus cos theta. Right? That is now speed of the object with respect to sphere as a function of the angle theta. Okay.